The next part is hexane will react with the chlorine in the presence of ultraviolet light to form the number of products. Describe the role of the ultraviolet light in the initiation step of this reaction. Again, since you have Cl, so this is for the homolytic bond breaking, it's half arrow, to produce two Cl radicals. So this is done by the UV light. So the role of the UV light, it's an energy for homolytic bond breaking of Cl bond. Now, alkane, dodecane, C12H26 is formed in this reaction. Write the equation for the propagation step and for the termination step for the formation of this product. The propagation step after the formation of Cl radical with it's with C6H14. This gives us C6H13 radical plus HCl. And when this radical is formed in the termination step, two of this radical was reacted with each other to form C12H26. That's the termination step. Okay, now the next question is about alkene straight. Alkene X has the structure shown. Draw the skeletal formula or formulae of that do not include geometric isomers. So first of all, you have this one. Did he ask you to name? No. So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the first one. And okay, the second one is 2, 3, 1, 2, 3, 4. And here we have 1, 2, 3, 4, 5. And this one, it's not geometric isomer. And another one is this one, where we have like this. Okay. And maybe 1, 2, 3. 4. 1, 2, 3, 4. And it is not a geometric isomer. 1, 2, 3, 4, 5. That's it. All these structures, they are not geometric isomers. Okay. Now, explain why X can exist as a geometric isomers. If we return back to X, it's like that. So here this is X. 1, 2, 3, 4. Sorry. It's 1, 2, 3, 4, 5. So we are talking about X 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, and this is 5. So why it includes the geometric isomers? Here we are talking about CH3, and here we have H, and here we have CH2 and CH3, and also we have hydrogen, which they are not clear, and you can see this is like that. So you can convert this structure like that, where CH2, CH3, and here you have H, and here you have CH3H. So you can see that you have 2 or 4 different substituents, or 2 different substituents around each carbon. So the restriction of rotation around the double bond is clear. Since the 2 carbon-carbon double bonds includes 2 different substituents, this means that they are geometric isomers. Another compound Y has the structure shown. Give the IUPAC name of Y. Now to name this structure, it's 1, 2, 3, 4. And because the chlorine high priority comes on the opposite side, and they are different, so you can name it as E 2, 3 dichloro 2, 3 dichloro what 1, 2, 3, 4 but 2-ene. That's the correct IUPAC name. A student stated that the compound Y has a polar bond, so it is polar molecule. Comment on this. Let's see there. We can omit all these and explain the idea of the polarity. You know, this is partial negative and this is partial negative. So you can see that the dipoles are cancelled. So it is non-polar because the dipoles are cancelled. Dipoles cancelled. Okay. Now, bisapolines are a group of the compounds found in the plants and fungi. Bisapoline molecules contain several carbon-carbon double bond. 5.51 grams of alpha bisapoline reacted with 1,873 cubic centimeter of hydrogen gas. So that's the volume of the hydrogen gas. The reaction occurs at the temperature of 150 degrees and the pressure of 152,000 Pascal. The molar mass of it is 204. Calculate the amount in moles of bisapoline and 551 grams. Okay. Now, let us calculate. You know, the moles equals mass 5.51 over the molar mass, which is 204.0 equals, so it is 5.51 grams, 5.51 over 204. This equals 0.027 moles. Okay. Now, calculate the amount in moles of hydrogen gas that's reacted with, okay, you can calculate it like that. He gave you the pressure, which is in Pascal. Sorry. So we can apply the number of moles equals P V over RT. So this equals the Pascal moles. Let me take it from the paper itself. So the numbers are where the V is, okay, now PV over RT. So the pressure is how much? Let me tell you from the question. The pressure is 152,000. So it is 152 times 10 to the power 3. Okay, this is times, what's the volume in meter squared? It's 1873 because he gave you the volume in centimeter cube. So it's times 10 to the power negative 6. And this is over 8.31, which is the value of the R, times the temperature, which is converted into Kelvin, which is 423 by, okay, and the answer is 0.081 moles. That's the answer. Now, deduce the number of carbon-carbon double bonds in the molecule. We can define the ratio between the number of moles, which is of hydrogen, to the number of moles of the answer, which is 0.081 to 0.027, which is how much? It is around 3 to 1. So this means that we have 3 carbon-carbon double bonds. And after that, the repeated unit of the polymer polyisoprene is shown. Draw the skeletal formula of the monomer polyisoprene. It's very easy. Just remove this unit. Okay, remove these units. So it is like that. So it will be like that, because the carbon-carbon double bonds, that's the structure. Okay, that's the monomer. And the sample of polyisoprene has a relative molecular mass of 50.5250. Calculate the number of repeated unit in the sample. First, you can find this is the repeated unit. Okay, you can calculate its mass. The mass is 100. It's 68. The mass of this unit is 68. Okay, now because it is C12 3, 4, 5. So 3, 4, 5. So it's C5H8. 5 times 12 plus 8. Okay, let me calculate that. So it's 68. That's it. It's 68. Now, if you divide 50, 50250 over 68, you got the answer of 738.97 units. So we are talking about 739 repeated units. Okay. Now, the final or the next incinerators used to dispose polymer waste have a systematic or a system to remove waste gases, suggests why these systems contain solid calcium hydroxide and why it says finally powdered. It is to remove, it's a base, to remove waste acidic gases like SO2, NOx gases, and finally powdered to increase, to elevate the rate of reaction. And next, the question is, or this equation is about the mineral containing metallic elements. The green mineral Zaratite contains basic nickel carbonate, blah, blah, blah. Basic nickel carbonate can be formed by the reaction of nickel 2 sulfate with sodium carbonate under the alkaline conditions, and he gave you the molar mass. Just you can find the molar mass of this structure, which is exactly how much when you add the atoms and their numbers. So it is 3 times 58.7 for nickel. Where is nickel? It's there. Plus carbon, which is a 12, plus a 3 times 16, plus 4 times 17, which is 4 hydroxide, plus 4 times 18. So we got the final answer, which is 376.1. Okay. Grams per mole. Calculate the atomic economy by the mass of formation of nickel 2 carbonate. You find out this, and if you find the molar mass of the products or reactants, you can find all the products they are 8. So if you found the all products, it's 8 to 4. So the atomic economy equals 376.1 over 80.24. This is times 100%. This will give you the atom economy. So the answer is around 46.889. Sorry, so it is 46.9%. And give the reason why the use of the term relative molecular mass is not appropriate. This is because it is relative molecular mass is not appropriate for AI, I mean, it is nickel carbonate, nickel 2 carbonate by the reaction shown. So it is hydrated nickel carbonate because it's an ionic substance and it is not simple molecular. It's ionic and not simple molecular. Okay, my students, everything's okay. Chemists often simplify full chemical equations into ionic equations by removing the spectator ions. Give the electronic configuration of nickel ion in the presence of present in the nickel 2 compound. You know, nickel has the atomic number of how much? It is, we have 1s2, it's a 23, which is 20 what? Let us return, if you return back to the periodic table, the nickel, it's in the paper itself, you can find that. Here is the nickel. Where is nickel? Where is nickel? It's a 28, as you can see there. It's a 28. So you can return back 28 minus 2 electrons. Now nickel positive 2, so 1s2, 2s2, 2p6, 3s2, then, okay, 3s0, sorry, 3s2, sorry. Let's do everything correctly. Ni positive 2, it's 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d because 4s2 was lost. So we are talking about 8. Now write the ionic equation for the formation of nickel 2 carbonate from the nickel sulfate. State symbols are not required. So he gave you the equation. You can write it without the spectator ions. You can see that it is 3 nickel exist, sulfate 3 ions are cancelled, and the 3, 4, and 6 sodium was cancelled from there and there. Okay, carbonate was cancelled. Okay, carbonate was cancelled, and at the end you will find this is a this is a precipitate. Here it's a precipitate, there nothing cancelled there. So you will find that the overall equation 3Ni positive 2, okay, plus CO3 negative 2 plus 4 OH negative 1 will give us plus also 4H2O. This will give us Ni3CO3 OH by 4H2O solid. Okay. Another basic carbonate found in the minerals contains the metal element X, and it's formed by the reaction shown. 2X is 4Na2CO3 H2O, X2CO3, and 2Na2. 199.5 grams was reacted with excess Na2CO3, forming 150 cubic centimeter of carbon dioxide at room temperature and pressure. calculate the relative formula mass of this. First of all, we can find the number of moles of carbon dioxide. So moles of CO2 equals 150 over 24,000. This will give us 6.25 times 10 to the power negative 3 moles. By using the molar ratio, it is times 2. So the moles of XSO4 equals 6.25 times 10 to the power negative 3 times 2, which equals 0.0125 moles. Then this is the number of moles, and he gave you the mass. The mass over molar mass will give us, so the molar mass equals 0. The molar mass over molar mass will give us the number of moles. Mass equals mass over molar mass. So the molar mass equals the mass over the number of moles. So the mass is 1995 over 0.0125. That equals how much? It is 159.6. Then I guess he will ask you to deduce the identity of X, which is very, very simple. You will find it because it is XSO4, so you can find it by 159.6 minus 32.1 plus 4 times 16, which is 64. This equals 63.5, and that's what for Cu or Cu positive 2. If you return back to the periodic table, you will find that the molar mass of copper is 63.5. Like that, my students, you can get full mark in your external test. Thank you for watching this video in our platform MetaStars. It's your way for A star and A's in your A level. Thank you for good listening.